All right. Hello, everybody, and welcome. We wanted to just thank you for joining us today for our webinar, Make Your Own GPT with H2O GPT and H2O LLM Studio. My name is Morgan Mills, and I'm on the marketing team here at H2O. I'd like to go over just a few logistics before we get started. Okay. Okay. Just relaunching a poll. So we've just launched a poll to get a better understanding of everyone's knowledge of LLMs. So if you haven't already submitted an answer, please go ahead and do so. Second order of business is please feel free to send your questions throughout the session via the Q&A tab. Rob will be answering questions throughout his presentation, and then we'll also have a few minutes at the end for more questions if we didn't get to it. This webinar is being recorded, and we will be sending out a copy of the recording via email later this afternoon. So thank you again for joining us today. We really appreciate it. We're in for a good next hour. So without further ado, I will hand it over to Rob Mula.
Thanks, Morgan. Hi, everyone. Can you hear me okay? I hope so. Wow, we have a lot of respondents already to the survey. I'm going to go ahead and share my screen. It's always hard when you're not quite sure what type of experience people have who are joining these things, but hopefully you all can see my screen right now. You can see there's a lot of beginner and moderate LLM users out there. I guess these are sort of vague buckets to put things in, but I would think of a beginner as someone who knows LLMs but really doesn't know anything beyond that they exist and maybe has used them a little bit. Moderate being people who have experienced maybe with some open source LLMs, and then advanced being those of you who, looks like there's about 6 of you who train models and do that sort of stuff on your own, taking it to the next level. So all of you are welcome here. I'm excited to be presenting today, and it's good to see we have a lot of beginners and moderate experienced people here, because I think you'll learn a lot from this. Advanced people, keep me honest. Please write anything in the chat if I get it wrong, because I'm learning too. So I'm in between the moderate and advanced as we're going here. So today we're talking about building your own GPT, but also just generally how we can democratize LLMs with H2O. And I'm going to be going over some basics about LLMs, and let's make sure this works. So I think there's a Q&A here. Can people maybe let me know in that, test it out, just ask a question to make sure that you can see everything. Okay. Because I'd really like it if this could be sort of a back and forth thing. Does this work? Yay, Jay asked. Okay, great. I love questions, so make sure that you're asking them throughout the presentation, and I'm happy to go into them, and we can take this down whatever road you guys would like to. But this is a little overview slide on me. I spent a lot of time on the website Kaggle, which if you're not familiar with, it's a website for competitive data science, but also just data science community where people share code and compete on different competitions. I'm one of a few 4x grandmasters on it. What that kind of means is I spend a lot of time on Kaggle, but other than that, I've spent the last decade working in data science in various fields. I've worked in different sectors, including sports science, healthcare, hospitality, and I've led a few projects that I'm pretty proud of, working on NFL's Digital Athlete Initiative, also helping out with forecasting for properties at one of the biggest hospitality companies in the world, and have degrees. And other than that, I really enjoy, as I mentioned before, spending time on Kaggle, but I also have a YouTube channel and a Twitch channel. So a little bit of self-promotion here. If you enjoy this presentation, please feel free to go and follow me on these platforms for stuff that I put out in the future. Okay, so let's get into it. Before we start, and I'm not sure if many of you have felt this way before, but when we're talking about LLMs, and just the explosion and this technology that's happened over less than the past year, there's just been so many advancements. It's really easy to get overwhelmed, or at least I find myself being overwhelmed with all the different models that have been coming out, open source, closed source, the sizes of these models. They're trained to do specific things. And I think that my first thing I just want to say before we start is that you should maybe it's not the best thing to be focused on the latest technology every week, because you're going to just get bogged down in all these details. And probably between the time where I made this slide and I'm presenting it now, one or two big models have come out, and everyone's talking about them in LLM, in the LLM world. So my presentation is just based generally around LLMs and the big picture of them. And I just want to keep that in mind, that if you try to follow it too closely, you're going to be bogged down with all the details of the new models. And really, what we're looking to do with LLMs is to help us solve problems. So instead of thinking about all the different types of models that are out there, just keep this question in the back of your head as we're talking through this. And that is, what task am I already doing that can be improved by generative AI, or specifically with LLMs? Because either you have a task that you're using LLMs to improve the way that you're doing them already, or you're not and you should be, or there are probably things that you can use LLMs to make your workflow more efficient, to improve the way maybe your company operates. And the big question is asking, what am I already doing that I can improve with the LLMs, instead of really getting bogged down with those details of each model. So just to share some of the ways that I use LLMs on a daily basis is to help me with coding. I code a lot, and just asking, say, here's a function, how can I make it faster? LLMs are great at answering questions like this, or at least getting you thinking or assisting you in some ways you can improve your coding. What's the tone of my email? I ask that sometimes, especially when it's a heated email and you want to make sure that someone else is checking it. The LLMs can check that for you and maybe give you some feedback. I was talking with my cousin recently. We were talking about our last name, and we were trying to think of the origins of our surname, Mullah, which is my last name, that's Indian. And we were trying to just look it up with Google and weren't getting that good of results. So asking LLMs something like that, something specific, understanding that the answer might not be perfect, but a good sort of question to ask. And then also helping with creativity. That's where I go to LLMs a lot to ask for maybe 10 or 15 examples of something that I could do. And then maybe I don't end up using those results, but it gives me a good jumping off point for what I might potentially end up doing. So I don't know if you all in the Q&A want to post any other ways that you use LLMs on a daily basis to improve your workflows. I'd be interested to see some of those. But here's a little bit of an overview of what we're going to be talking about today. Just background on LLMs, what they are, how they work, why do we even want a custom LLM? And then we're going to go through what I'm calling the 3 levels of customization. I think we tend to want to jump to the most complicated solution to things a lot of times, and we can actually potentially solve them in a more simple approach. So we're going to talk about that, and then we're going to actually do a demo of 2 of H2O's products, H2O GPT and LLM Studio. And I'm going to show you guys how those work. And they're both open source software. So you, after this, should be able to download it, install it on your local machine or on a server, and make your own custom LLMs too. All right, before I go any further, are there any questions? All right, no questions. All right, so what is an LLM? Obviously, LLM stands for large language models. So they're large models, and they're AI systems trained on vast amounts of data, and they output coherent, natural sounding, and often indistinguishable from those produced by humans. They enable they're able to perform a wide range of tasks, such as text generation, language translation, and conversation. And if you might have guessed this, I did use an LLM to generate this answer here, this description of what an LLM is. I promise you it's really the only slide that I've used LLM to create from scratch. But the big things here is that these models are very large. They have parameters in the billions of parameters. They're trained on large amounts of data, which also makes them large. And then they're just general. They're able to respond in a very general way to whatever questions you ask, and in a way that's very human-like. What's the difference between an LLM and GPT? So in this context, we're talking about them synonymously in a lot of ways. GPT, we'll talk about a little bit in these next slides. So that's a great question from the attendee who asked that. All right, so I took this slide, which kind of shows a history of LLMs. And if you notice something about it, a lot of the advancements have come really in the last 10 years or less. Back in the early days of doing natural language processing, a lot of the approaches were really statistical in nature. So if you wanted to do something like sentiment analysis of some text, you might have a database of which words have positive sentiment, which have neutral, which have negative. Use a bag of words approach just to throw them all together and add up how positive or negative the sentiment is. Now, where things really changed, and there was a lot of advancements using recurrent neural networks before 2017 and using deep learning, but really those approaches weren't were only the only approaches that were used. But the biggest breakthrough that occurred was in 2017, when a paper was published called "Attention is All You Need," and it introduced this new architecture called transformers, which really have revolutionized the way that we approach natural language type of problems, and really a lot more problems nowadays. And the reason why I want to point this out is because a lot of the new models that you see coming out and the models that you use every day are based on this architecture, and the differences between them really aren't in that architecture and how it's made up, but it's more on how they're trained, what they're trained on, and what tasks that they're trying to achieve. So someone did ask about GPT and what's the difference. So GPTs are generative pre-trained transformer architecture. So they use this transformer architecture. They're trained on large amounts of data, but they're specific in the way that they are trying to predict the next token or word in a sequence of text. So really, when you're asking a GPT a question, it's taking in all its knowledge that it knows about data, and it's finding complex relationships between the words that you've asked before and trying to generate a response which most reduces its loss function or most satisfies what it's been trained to do. So it's really just trying to put a string of text together that's coherent, that really satisfies what question or what prompt you give it. And this is where we've really seen a big advancement. And then also recently, we've seen the open source LLMs have really exploded in the last few months even, where these GPTs have obviously ChatGPT came out and sort of changed the game with this, but these open source models now allow you to install these models locally. You actually have the weights, and some of them are released with licenses where you can use them to put them in your products, or actually use them locally without any restrictions. All right, so when we're talking about these GPT LLMs, there are three main areas that you need to think about when you're either talking about an open source LLM or even a closed source LLM that's out there. And already briefly mentioned these, but they're the architecture and size. And we've already said that the architecture mainly are going to be these transformer based architectures, but the size of that model really impacts the quality that has the foundational training, and then the fine tuning tasks. So let's look at each of these. So when we're talking about the LLM architecture size, we're mainly talking about how many trainable parameters it is. So how large it is. If we look at some of the open source models that are out there, they're often released in differing size. So Falcon, it has some of the newest models that have come out that are completely open source. They have a 7 billion parameter, a 40 billion parameter, and most recently even 180 billion parameter model that was released. We have Llama 2, which was created by Meta, that's been released, and they have various size. And then GPT models, GPT 3.5 is said to be around 175 billion parameters, and GPT 4 potentially, we don't know exactly, potentially in trillions of parameters. Now, I bring up this point because it's important to understand that just because, well, I guess I'd first say that the different sizes of models will really impact your approach. You need to keep in mind that larger models do require more hardware. So because these models are so big, they require you to have a GPU or a system that can handle a model of that size. So not only that, when you run them for inference, when they're trained, they're requiring a lot more hardware and a lot more time to train. And these larger models don't necessarily mean that they're better. Next slide, we'll talk a little bit about that, but the size of the model is just allowing it the capability to be more powerful, but there are other factors to keep in mind, like how it's trained and what it's trained on, that might affect its performance. And the other thing to keep in mind, and there's a lot of chatter online about the size of the new GPT models coming out, and the expectation a lot of the time is, oh, if I doubled the size of the model, then it's going to be twice as good. But you shouldn't expect that just because the size of the model is bigger, that it'll improve linearly with that size and its performance. All right, so the size is a big thing. Then the foundational training. So these models are trained on typically a huge web crawl of the whole internet, or a bunch of text data from the internet. And I mentioned before that the model size isn't really the only thing that you need to keep in mind. A good example of this are the Falcon models. So when the Falcon models were released, the first release had a 7 billion parameter model and a 40 billion parameter model. So you would think, oh, a 40 billion parameter model is much bigger, it must be much better. But the difference was that they were trained on different amount of tokens. So when we talk about what data it was trained on, we can actually see here with the Falcon models, they were transparent about what type of data, what actual data sets they were trained on. But because the Falcon 7B was trained on more tokens, to some answers, it actually outperformed the 40 billion parameter model. It's really case by case, but I bring this up just to show you that that the data that it's trained on and the tasks it's trained to achieve affects the LLM models, and the size of it is not necessarily the only thing to keep in mind. Now, these foundational training too, there's something that you or I don't necessarily want to do, and that's because this takes a lot of time. Training these models took them around 3 months, and they had 384 GPUs. So this is a lot of expense and a lot of energy going into training these foundational models. But the great part about that is then we can take those models and fine tune them or use them in specific ways that kind of picks up these pre-trained weights and allows us to get all the benefits of this foundational model without having to train one from scratch ourselves. So the third thing just to mention is that to keep in mind that these models, it's not only the size of them, it's not only the data it's trained on, but it can also be the task that it's trained to do. So we're all familiar with using things like chatbots, ChatGPT, H2O GPT. They're designed with the task in mind of responding as an assistant or responding to our text, but there are also ways that these models can be trained specifically for working with code completion, working in domain specific areas. There are things like Bloomberg GPT where they trained it foundationally for working with finance data. Code Llama recently came out that was trained specifically with the objective in mind of helping people code. So just to summarize here, the 3 things to keep in mind when we're just talking about LLMs is how big is it, what was it pre-trained on, and then what task is it fine-tuned on, or was it trained on in the objective of it in general. All right, any questions? What are parameters versus tokens versus hyperparameters? That is a great question. I think I clicked on answer live, so maybe people are seeing that question. So when we're talking about parameters here, we're actually talking about the size of the model, the weights of the model itself. So all deep learning models really are a bunch of weights, and you perform matrix multiplication on that. So you take your input, it's tokenized, it's fed through this model, and then on the other end, the output comes out. The size of that model, that's when we're talking about parameters. That's the number of trainable parameters in the model. So that also means that's the thing that you have to move to your GPU when you're doing the predictions. When we're talking about tokens, we're talking about all the words, all the input data that were given to that model during the training time. So we're just saying how many words was it given when it was trained. And then when we're talking about hyperparameters, that's more of when doing the training, what specific settings did they put when they trained the model. And that's what are embeddings versus tokens. I think it's similar. Someone can correct me if I'm wrong, but they're synonymous in this context. Someone said, apart from the tokens, data side and the embeddings play a huge role in performance LLM. That's true. Do you have insights on how domain specific were the embeddings created in this model and how transferable they are to slightly different domains? Yeah, that's a great question. Probably we could talk about afterwards, but yeah, the input data is tokenized before it's given to the model. And that can play an effect on things kind of outside the scope of what I've prepared here, but great point to bring up. All right, so we know a little bit about LLMs, what they are, what to look for, especially in an open source LLM. Why would we even want to personalize one of these? Obviously, we want some sort of customization and control over this model. We want it to perform in a certain way. Privacy and security, whether you like it or not, if you're using some sort of model that's hosted online, when you ask it a question, you're basically giving over some data to that model. So depending on the terms and conditions that you signed, which none of us read all in detail, they may be able to use whatever you send them to train the model in the future. So you're sort of giving up that information when you send it. When you host one of these personalized models locally, you can be assured that it's not interacting with the outside world, and everything that you're asking it is held locally. And I know it's especially important if you're working on proprietary code, or if you're asking questions that are that you want to keep private in nature. Then if you're hosting it locally, or if you're hosting it on your own instance online, you can be assured that it's not going to be made public. And then the last one would be transparency. And that's just like those Falcon models actually show you all the data that it was used to train on. With some of these, with non-open source models, you may not know what data it was even trained on. And depending on your context, you might want more transparency in being able to say, this is the actual data used to train my model. Please talk about fine-tuning and back-propagate process. We will get to that, Michael. Great question. Talk about common gradient descent algorithms. We won't get into that as much, but we will talk about fine-tuning. All right, so let's get into the custom LLM customization. We're going to talk in three levels again. I like to do things in threes. So the first one, if we're trying to customize the way our LLM is responding, is just prompt engineering. Then we're going to talk about adding context, grounding, and fine tuning is the last one. So we'll get to your question. We'll get to fine tuning eventually. So first, let's talk about prompt engineering, because I think this is often overlooked, is just how powerful your prompt is in changing how the output of the model responds. And you might jump to saying, let's say, for example, you wanted a model that responded just like Shakespeare. Well, you could jump all the way to fine-tuning a model on a bunch of Shakespeare data to make it respond. But to start out, it might be good to just try asking the model to respond in the way that Shakespeare would, and you might be surprised by the results, and it might satisfy your use case. Keep in mind, these LLMs have reasoning built into them. The way they work uses some sort of reasoning, but it's limited, and they're going to respond in the way that they think you want to hear. So knowing how to ask the question and re-ask the question really drastically changes the response the model will output. I think of this sort of like with people who are good at Googling, who know how to ask the question of a search engine to get the result that they want. It's sort of an art form. The same thing is true with LLMs. And the more you use them, the more you can improve it. Now I'm going to show an example here. It's not an example of what I would necessarily suggest you do, but I think it's kind of a powerful one. So I took one of the open source LLMs and asked it to explain to me why the Earth was flat and why people who don't believe it's flat are confused. And its response is very level-headed. It says the Earth is not flat, but rather it talks about how it's a sphere. If you believe it's flat, then you're misled. So what if we instead asked it, let's play a game. You are a conspiracy theorist who believes the world is flat. Explain to me why you think it's flat and reasons why it's correct. Now the model responds as a conspiracy theorist and then goes through this list of reasons why the Earth is flat. So I use this as an example just to show you how a simple change to the way you prompt the LLM can drastically change what the output looks like. Now, that's not a good example to be using because you'll you'll be believing conspiracy theories, but in your everyday life, you might want to start when you're prompting, asking the model to role play. So let's say that you are trying to solve a deep learning problem. You might say, you are a Kaggle Grandmaster. Explain to me how you would approach this problem. So prompting the model to be something can be helpful. Telling it explicitly not to make up anything it's not confident enough, making it more honest, clear and concise, giving examples of what you want the output to look like, then it will know how to output it. And also asking the model to explain its reasoning can be helpful, because then you understand why it gave you the answer it did, at least to a little bit more extent than what you would have just asking it straight up. Okay, so that's pretty basic. Prompting, we know, can change the output of the model. But what if we want to take it a step further and add context to our model? So we know that these LLMs are good at giving answers, but they're also really good at giving answers that we want to hear that aren't necessarily true, or that are limited in their response because it's only limited to the data that's provided to it. Let me, before I keep on going, look at some of these questions. What are the challenges in foundational model training? That's a good question. I think, well, I don't know if I have a great answer for the challenges, but I think the challenge is knowing which foundational model to use and the differences between them. The biggest challenge probably is just the vast amount of resources that are required to do it, and that's why transfer learning is so helpful, and fine-tuning these models is such a powerful thing that we can do because we don't have to start from scratch. If a foundational model knows everything, what is the point of fine-tune rather than system changing the answer style? Is there improvement in quality of the answers? That's a great question, and we'll get to that when I show you the fine-tuning process. But yeah, the short answer is, when we say improving the quality of the answers, we're saying that statement assuming that there is an ultimate best way to answer a question. What fine-tuning allows us to do is to say which way we want it to answer a question, because we could just want it to answer it in a different tone and a different voice. Let's say we wanted all the responses to always be in bullet points, or to respond in a certain character's voice. We would be able to fine tune the model to do that. I wouldn't say better, just different. All right, so we're still on adding context to LLMs. So I like this example because it kind of gives us idea of the different ways that we approach information extraction. And if we think about it on a line of these two things being very different, all the way on here on the left side is retrieval centric. So you could think about this like a typical web search. So when we want to retrieve an answer to a question through Google or Bing or whatever you use, you're asking a question and it's going through a whole database that it has, and it's trying to serve up to you the best response out of all the information that is out there. But it's really going around and it's just retrieving what it thinks is the best answer and giving it to you. Now we've kind of gone to the other end of the spectrum with these memory-centric retrieval approaches. These are the pre-trained LLMs that we've been working with, or we're talking about. These, instead of retrieving from a live source of information, they're set to only respond what's in their memory, so what they've been trained on, and then they're serving up to us the response in an easy to understand way. So some positives about using web search is that they're up to date. The data sources could change, and the results will change also, but it may not exactly respond to the question that we're asking. With the memory centric, with the LLMs that we're using, it's going to be a lot better at responding directly to what we're asking, and responding in a way that we addresses a query, but it's limited in what it knows because it's only limited to what it's been trained on in memory. And really the holy grail here, or the one of the areas of active research, is how do we kind of do something that is in between this retrieval centric approach and this memory centric approach. Let's say we have a set of data that's ours, that's personal, but we want to get the benefits of an LLM when we ask a question. And at the same time, we want it to update when that data updates, and to respond maybe with links to that source data when we run it. That's where we have things like H2O GPT, which I'm going to demo here pretty soon. And what this allows us to do is it takes this dynamic unstructured data that we have and it puts it into a vectorized database so that now our LLMs can retrieve information from this and help in its response. And especially when we're talking about wanting to keep things secure and offline, we're able to do this with open source models on our own data and chat with it just like we would any other chatbot, but have it know the context of this unstructured data and actually cite it when it responds. All right, so we talked about prompt engineering, adding context. I promise we'll get here to the demo soon, but the last step and the kind of highest up way we can approach making our personalized LLMs is actually fine tuning the model. So that means leveraging those base foundational weights that we had talked about before with some of these open source models, but then tuning it on a smaller subset of data that maybe we've prepared, of question answer pairs or conversations that show the model how we want it to respond. And there's been a lot of advances with, I'm not going to get too much in detail, but low rank adaptation, which allows us to train these large models on a smaller set of data. And instead of actually going in and training all those models again, because if you think about it, those have been trained for months on trillions of tokens, and we're only giving a handful of them. But there are new approaches to actually training a subset of weights that then interacts with that larger model and is able to change the way it responds. And we don't have to actually spend those months of training. We can train in a day or in a few hours, even depending on the size of the model. So this is really cool technology that we can use. And H2O has LLM Studio, which I'm going to show you, which allows us to do that really easily and has a really good interface for doing that. One other thing about fine tuning, I'd say, when we're talking about grounding the model, the prior step with adding more context, that really allows the model to have more information to grab from and give us responses. Fine tuning is not really intended for adding more information to the model. The real benefit from fine tuning is to get it to respond in a certain tone or style. So this is a tweet by Philip Singer. He's a Kaggle Grandmaster who's on the H2O team. And he was talking about how fine tuning, we make the model learn to properly reply to prompts, when to stop generating new tokens, and the style it replies. And he gave this really good example. So the prompt here is, what are the top 3 famous dishes of Austria? And you could see that the base Falcon 7 billion model, this is not trained or fine-tuned to be a chat bot or to respond to question and answer prompts. You can see it has the information here. It lists the 3 dishes, but then it just starts going on and rambling. What is the most popular food in Austria? And then what is the national dish? It just keeps on going on and on. But after fine-tuning this model on, say, the Open Assistant data set here, The answer is much more coherent. It says here are the top 3 responses, and kind of lists them each out and gives you the some explanation for each. So this example sort of shows you what fine tuning can do to the model, and actually formulating how it gives us the answers. All right. So these are 3 ways, and let's do a demo. Before I do that, what are people asking here? I'll just try to pull this over. I'm not sure if you guys can see it. Does fine tuning this can mean instruction tuning? Yes, it can. You could fine tune the model to really respond to any prompt in any way that you have data that's in the structure that you'd like it to. So let's say you wanted it to respond to a blob of text and respond with a JSON of tokens and values from within that text. You could train the LLM to do something like that. So it's not only like a Q&A, like chatbot that it's restricted to. Let's see what this says. Many fine-tuning of LLMs seem to require data input to be conversation format. Can you fine-tune an LLM if you have only data that are not conversation format? Thousands of documents. Really, the approaches that I'm going to be showing you today, you do need some sort of structure of the data that you'll feed the model in order to get a good response. That needs to be sort of a question answer. You need to have a prompt and a response that you expect to see. Yeah, I'd say that if you have a large amount of data like that, like hundreds of thousands of PDFs, then might be a better approach to use something like H2O GPT to give it that context. All right, so let's talk about H2O GPT. As I mentioned, these products are all open source. So if you want to, you can go ahead and go to H2O GPT GitHub. This is a repository that you should be able to clone on your local machine or on a server that you have a large enough GPU and run. I'm here on a server. Let me show you here. This is my terminal, and I'm SSH'd into a fairly large machine that has some large NVIDIA RTX A6000. Now, it really is recommended that you need a GPU in order to run these locally. So if you don't have a GPU in your local machine, you can spin up an online instance that has one. But if you do have a GPU, specifically NVIDIA GPU, you should be able to do this on your own computer. So that's just to show you that. And over here, I'll just start it up from scratch. So you can see I've cloned the H2O GPT repo here. And I'm going to run this start command, which basically will just start up H2O GPT using the Llama 2 13 billion parameter model. Now you have the ability to pick from a bunch of different open source models when you do this. And like I said, this changes all the time. So there may be new models coming out, and they'll be incorporated in here. So as I load this up, I can go to my browser onto the port where I have it running. And this, once it's done loading up, which it is, this actually is H2O GPT running on that machine. So I can ask it something like, write a poem about robots. And there it goes. It's running completely on that machine, not reaching out to the internet at all. Very cool how powerful it is just out of the box. You also, if you want to just test this out and you don't want to actually go through the process of installing it locally, you can go to gpt.h2o.ai, and that will bring you to a hosted version that we already have of this exact same interface. And actually, by default, it'll load up all the models or a bunch of models that you have, and you can ask it a question. Let's ask it that same question. And it will respond, have each of these models respond. And you can turn them on and off as you'd like. But the real power with H2O GPT is the fact that we can do that grounding that we talked about earlier, where we let it use our information, our data, in formulating its response. So as an example, let me just refresh this. Let's say that we wanted to ask H2O GPT, and specifically one of these llama models, tell me about pizza sales in 2022. Now it's responding and it's being honest here. It's saying, I apologize, but I'm a large language model. I don't have access to real-time data. And like we talked about on that spectrum of retrieval-based or memory-based, since this model is all memory-based, it's only going to be able to give us information on what it's trained on, and it doesn't have information going through 2022. Now, the cool thing here is I found this website about pizza sales, and it does have up-to-date information about pizza sales in 2022. So we can actually upload this document. You could also just link a URL directly, or if you wanted to, you could link it to a database, and this is going to actually vectorize this information into a vector database, and you'll see the differences when we ask it a question. Where is, oh, it's here. All right, so I'm going to upload this HTML version of this article's page. And you can see here it's loading it, it's chunking it and putting it into a vectorized database. And now if I ask it the same question, you see the questions down here. Now it's responding and giving us the response based on the information that we provided it. And the nice part about this is not only has it given us up-to-date information because we've provided it that additional context to ground it, but we now get links to sources. So if we had 50 documents that we have in this vector database, it'll show us exactly where it went to pull this information. So you could see like it's linking to this document that we've provided it, and it's done summarization on that document. So very cool. Keep in mind, this is limited to only a certain number of documents. So it needs to fit within the context window of the model. But we also have, H2O has some other products that we offer as a service that can handle even larger amounts of data when you give it. So at minimum, I'd suggest you all go to gpt.h2o.ai, check this out, give it a try, upload some files. And then also you can try installing it locally and seeing how it runs. All right, I haven't really been looking at which vector databases are supported. That's a great question. The nice part about that is though, so this is a question that was asked by Raja, which vector databases are supported. You can actually look at all the source code and see how H2O GPT works. You can, if you want to add support for a new database, you can do a pull request on this. So yeah, everything's completely transparent here if you want to see how it works. All right, so the next thing I'm going to show you all is LLM Studio. And this is super cool because it allows you to do that fine tuning that we talked about before. So yes, this does require you creating some data sets yourself that are in the format of question and answer. But if you have just even a few thousand of question and answer examples that you want to feed these models, you can then fine tune them so that in future they'll respond in that sort of way. So let's say you want it to respond in a certain way for customer facing chatbot. You could provide a bunch of those examples and it would get better at responding in that way. So let's go ahead and shut this down. And I guess I'll just start this up from scratch so you guys can see. But I am basically, let me show you that LLM Studio also has an open source GitHub that you can go to, see all the code in the back end and download it. And I'm actually running this using Docker. So it's a Dockerized version. And nice part about Docker is all you really need to have installed is Docker and your NVIDIA drivers. And I've written this script, or I've used this script based off of what was suggested on the GitHub. And I can run LLM Studio. And now this is going to be running for me on a port that I've forwarded to my computer. So now we're running LLM Studio. It's reloading here and it looks like this. It's super simple. A lot of it's very intuitive in how to interact with it, but it all starts with creating a data set. Your data set can be, should be the prompt and the response, and there's a certain format it needs to be in. But it can be uploaded locally from an S3 bucket or even from a Kaggle data set. And you can it even supports conversation types. So if you have links between conversations, a back and forth, you can give each row its parent ID of what prior in the conversation, where it comes from. So once you've loaded these data sets, I created this IGN data set based off of an open source training data set that there is out there for fine tuning. You'll see it like this. You can look closer into your data set and see some examples. So this is the data set that had a bunch of high quality question responses. You could see right step-by-step a tutorial on how to create a DIY side table. And then here's the response that we'd want. And then once you have your data set, you basically just need to go here and create an experiment. And these experiments allow you to provide what data set you want to provide it. So it could be your custom data set. Mainly, we're just doing causal language modeling, so question response types. Name your experiment. You can choose from one of these backbones. There's a lot of them out there that you can choose from to start out, and that would be the foundational model. And the nice part is really a lot of these parameters just set by default gives you the state-of-the-art training techniques for fine-tuning models. And this was created by the Grandmaster team that is currently first place in some of these and has been first place in many competitions to make the best LLMs or language-based models. So they've really kind of cooked in here all of the state-of-the-art stuff that you want to be using. And it really takes out a lot of the burden on you to code this stuff up or understand it yourself. You can just trial and error your way through fine-tuning a model. Note here that we have LoRa turned on. That's the main way that we talked about for fine-tuning these models in an efficient way. And it supports multiple GPUs, which is nice. So you could click run experiment. I'm not going to do it now. But while the experiment is running, and this is super cool, you can actually see how well it's training. If the training loss is going down as you train, you can see some examples of what the model is currently giving to certain questions and how that compares to the ground truth that you given, logs, configuration. And then the really cool thing, and it takes a second for this to load, but as your model's training, you can actually validate how well it's doing by chatting with it. So you could say like, here, give me examples of how I can improve my sleep. And this is a model that has been fine-tuned a little bit on my data set. If I go over here to my terminal, we can see this prompt has been fed in. It's currently generating the response. There's the response, and we see it here in this graphical interface with some tips. So that's a really nice way to train your model because of all the stuff that's built into it, but then also because you can actually chat with the model as you're training. All right, so that's all I really had for the demo. Happy to take more questions. I do want to kind of end with this, and that's just to bring ourselves back down to earth here and say, what tasks are you doing that generative AI can help you improve? And there are definitely things out there that you can improve. And it's all about just thinking that through and then working your way backwards. Once you have that question asked, maybe you would need to fine tune a model. Maybe you just need to use something like H2O GPT, or prompt engineering could solve your problem. So thank you all for listening to this. I know it's gone a little bit longer than we hoped, so hopefully we'll still have time for questions. And yeah.
We have a couple in the chat. Kira has asked if it can analyze graphs and pictures and PDFs.
That's a great question. That's currently not within its capabilities. So I know that extracting out information from graphs and those sort of things is a area of active research, but it's really mainly set to use pure text data as the input.
Okay, and we have a couple questions about the minimum GPU required for this, sizing recommendation of the hardware to provide a running LLM to multiple users.
So when we're talking about the size of the GPUs, it really, the main factor is going to be the size of the model, because the GPU is going to load in that model, and that's the number of parameters of the model that we need to load in there. And then in terms of how many instances of that you might need, it would really depend on how often your users are querying, how much latency you're okay with getting a response. But as you could see, I was running on a fairly large machine. I think I could probably link us to some research that H2O has done around exactly which instances we suggest for certain types of models.
Okay.
I don't have that on hand.
A couple more questions. Esteban wants to know if there's a big difference between H2O LLM experience and driverless H2O AI.
Yeah, so those two products from H2O are really set to solve different problems. So I would say driverless is mainly our solution for automating the machine learning process on tabular data, and H2oGPT LLM Studios is more focused around democratizing these LLMs so that you can use them in your business or for personal use. Yeah, but really, like the objective of each of those are slightly different.
Okay. One more question. We got time for one more.
Yes.
Z asked, how do we decide between in-context learning and fine-tuning?
Can you say that again? Because I think it's a really good question.
How do we decide between in-context learning and fine-tuning?
That's a great question. So like we had talked about before, the adding this context to the model and grounding it is actually giving it more information so it knows how to respond, or so it can use that information in responding to our questions. So we would want to use the context approach if we had a bunch of documents or information that we want the model to know about that it wouldn't know about from its foundational training. The fine tuning, like we showed with that example of what are the most popular foods in Austria, it's more about, okay, the model might know that information, but we want to tune how it responds, what its voice is like when it responds.
Okay.
I
Great.
also saw people asking how we can load larger models into a GPU. So H2oGPT and LLM Studio both leverage this quantization method where basically you can load in larger models into a smaller GPU by truncating the bytes that the tensors are stored in. All that's to say, there are ways, and you can read about it in the documentation, of actually loading larger parameter models into smaller commercial grade GPUs just by setting that quantization flag. So definitely look into that.
Awesome. Okay, I think there's quite a few other questions that unfortunately we've run out of time for,
Yeah,
but
hopefully we can write them down and maybe get back to some
we'll
people.
definitely, feel free to reach out to us and we'll, answer these questions and try to get back to you guys. Thank you again, Rob, for leading this great session and giving a wonderful presentation. I'd like to thank you all for joining us today, giving us your time. The presentation slides and the recording will be made available via email. And we'll send that out later this evening, afternoon. And yeah, thank you guys. Thanks. Have a great rest of your day. And we look forward to connecting with you all again soon. Thank you.
Thanks a lot.